Okay, we have a function like this, and we're asked to find the function with 2 put in it. That means we replace the x's with 2. So 3 times 2 squared is 12, minus 8, so we get 4. Okay, Pauline, Leila, later you can do that. Okay. The 2 is part of, this 2 I've substituted in, is part of the domain of the function, the inputs. And the 4 is part of the range, or the outputs of the function. So you put numbers in, and you get numbers out. Input, output. So the function is here. I put inputs in, inputs. All the inputs are called the domain, and all the outputs are called the range. So that gives x values and y values out. When I put them all together, when I put all the inputs and outputs together, so if I put, for instance, this one, I put in 2 into the function, I got 4 out, that can be the point then, 2, 4. I can plot that point on a graph. I've put 2 into this function, and I got an answer 4 out. So that is a point on the graph. And then you start 2, 4, somewhere up here, that's a point. If you continue to do all the points, and this is what your calculator can do for you, or you can do sometimes, it'll form a shape. And one of the points will be 2, 4. And if you did them all the inputs, all the outpoints, it'll form this shape. So that's what a function is. Okay. So I could put any number into the function and get an answer out. That answer will be on this line. That point or answer, domain and range will be on this line.
Do you have to know that, or is that just an idea?
No, that's what it's all about. Yeah, you have to. Does that follow?
Yeah.
Okay, so each function then has a different shape because it's got a different bunch of answers out when you sub in a different domain. Functions can't do this. That is not a function. It's something called a relation. So there's a quick and easy test for that visually we can do. It's called the vertical line test. If the graph goes through twice a vertical line, so this is the vertical line test it's called, twice, then it's not a function. So for example, a circle wouldn't be a function. It's something called a relation. It doesn't follow function rules. What's that mean? What's that more mathematically or algebraically look like? Well, that means if I have an x input, so let's say the x here is 2, I can't have 2 minus 4 and 2 plus 4. I can't have 2 different outputs for the same input. So one input can only have one output. Does that make sense? So only one x value has to give only one y value. You can't get 2 different y values for the one x value. So if I sub in a number, I can't get 2 different answers out. That's what that says. I can get 2, if I sub in multiple x values, I can get 2 different y values here. So the y values here are the same. Let's say this is 4 on y, so this is 2, 4, and this is minus 2, 4. That's okay. The horizontal line test is okay. That is a function. But a vertical line test can't cross more than once. So anything we're going to be dealing with will only cross. So cubic function, anywhere you draw a vertical line through it, it only crosses once, one answer out. Okay, so we're only looking at things that are accepted by this rule. Okay. Maybe that's too much information, but could be useful to know. The vertical line test is useful to know. Because they could just ask the question, is this a function? And if you draw a vertical line through it at any point and it crosses twice, it's not a function. Okay. So sometimes, instead of having to sub in numbers, we have to sub in letters. So what's f? So I'll use the function that's over here on this screen, 4 minus 3x minus x squared. If I have to sub in something like, that's not the question that's there, but I have to sub this into that. Won't always be numbers I have to sub in. Sometimes this is a function in itself, and I have to sub it in. So I just replace the x, and it creates a new function. It's actually a transformation of this function. So I've replaced every x with this new function. I put a function into a function. And I can simplify this down. I get 4, 3x squared plus 6 minus, oh, well, I have to square this. X4, wouldn't it be? What's the middle term? Minus 4x squared plus 4. And then I'd apply in the minus here and then addity-like terms. So I'd end up with minus x4 minus 3x squared. Add this one. It's going to be plus an x squared, I think.
No, it's just positive x4.
Yeah, but this is minus 3x squared. Is this positive x4?
Oh, it's minus.
Minus is positive x4. And then the minus, yeah, I know. You're going too fast for me. 10, take away 4 is 6. Okay, you get this. You get a new function. Okay, there's a terminology that when we put functions into functions, what's that called again? Composite functions, yeah. So, composite functions is when you're given two functions. So fx can be x squared plus 3. A second function, gx, 2x plus 7. And I need to combine these two. What happens when I combine them together? And it does matter what order I combine. Remember, we have these two ways of doing it. We do f g of x or g fx. There's two ways I can combine them. One gets subbed into the other. Which way around is which? So this way around, the gx function gets subbed into the f. And this way around, the fx function gets subbed into the g. So this one, the gx function, this is the function, and it gets subbed into this x. So I end up with, instead of x squared, 2x plus 7 squared plus 3. And I can square this out again, knowing my quadratics. 4x squared, what's the middle term going to be?
28x.
Very good. Just 28x. This one's not squared this time. 2 times 7 is 14, and plus, oh no, not 2 times 7. 7 squared is 49, and then plus this 3. And then I can just add the 3 at the end. And I have my new composite function, the two functions combined, one subbed into the other. Should they give the same answer if I do it the other way around, fx into gx? No, I won't get the same answer. Sometimes it can, but rarely. Fx into gx is probably the easier way around to do it. Now I'm going to put this in for this x, so I get 2 times x squared plus 3. So this x has been replaced plus 7. Tidied up 2x squared, x squared plus 6x plus 9 plus 7. Multiply in the 2, and you can tidy it up yourself. Be similar, but not quite the same. Okay, so 3x, when I multiply this, oh yes, you're right, sorry, I squared that bracket, you're dead right. I made a mess of that, I squared out the bracket. It's just 2x squared plus 13, my bad, I thought that was to be squared. Okay. Where's the thing? So how do I write the domain and range? Domain are all the inputs, range are all the outputs. How do I write them? So if I have a function like this first one over here that goes up here, has a vertex at 3, 4, continues forever, what's the domain of this function? The domain. No, that's one of the domain. That's one domain value has 3, but it would also have domain answers for x here. So like this would be a point, this would be a point. They'd all have different values. I missed that. Okay. It's all the values for x. How do I write? It can be anything for x, can't it? Because it's going to continue forever and get as wide as possible. So the domain is the x values I'm looking at. This one, if it goes on forever, we can just say x is an element of all real numbers. All real numbers, any number can be part of it. That's an element. So this is how we would write that.
Why element?
So it's a set. So this is from sets, which we haven't really done, but it's x can be, this just includes all the real numbers. So x is one of the real numbers. We don't know which one, but it would be all of them. It's a funny way of saying it. Just everything.
Is that the domain for extrapolating? Looks like that?
Yeah. Yeah. The range is not, though. The range is not all.
What does that say? XER?
Yeah. The range, Annika. The range does have a limit. It's not going to be all y values. What's the highest possible y value?
The vertex.
Yeah, so the highest possible y value is this 4. So other than that, that's the biggest one. It'll never get any bigger than that. That's the highest. It's not going to go up there again. It's going down both ways. So the y values are less than or equal to 4. Because it can equal 4 because it's at 4. And that's how we state the domain and range of a function.
Wait, is domain always the x?
Domain is all, no, sometimes, and we look at some functions later on that the domain is restricted. For example, if the function is square root of x, we can't get negative numbers here. So negative numbers are not allowed. So this